So what is Supabase? In simple terms, Supabase is an open source backend as a service platform that allows you to build applications much faster. With Supabase, you can set up your backend with just a few clicks and start working with databases, authentication, real-time subscriptions, and storage, all without managing your own server infrastructure. So here's a breakdown of what Supabase offers. At its core, Supabase uses PostgreSQL, which is a powerful open source relational database system. It allows you to manage your data with SQL, which is the most popular language for interacting with databases. Now that you have a solid understanding of what Supabase is and how it compares to Firebase, so what's next? In our next tutorial, we're going to dive deep into Supabase's database feature. We're going to put all of this knowledge to use by building a real-world project, a car parking application. We can have a look at some of the terminologies that we'll use to describe different parts of the car parking application to avoid any confusion. So first we'll have the parking area, which will refer to a large designated space where multiple vehicles can be parked. It can be an open field, a multi-story building, or a specific zone within a large complex. So it's the entire parking space around maybe a shopping mall. Then we'll also use a terminology like parking floor. This is a specific level within a multi-story parking structure. Multi-story parking areas are divided into floors to maximize space vertically. So for example, we may have the second floor of a parking garage. Next, we'll have a parking lot, which is a smaller section within the parking area, which could be designated for specific types of vehicles or users. For example, a lot reserved for employee parking within the larger parking area of a corporate office. And lastly, we'll have a parking slot, which is an individual space where a single vehicle can be parked. It's the smallest unit in the hierarchy of parking management, so we can have something like slot number 45 on the third floor of a parking garage. Great, so imagine a large shopping mall with a parking facility. So the parking area will be the entire parking facility of the mall, including all floors and lots. The parking floor can be one of the levels within the multi-story parking garage. The parking lot can be a designated section of the parking area, like a lot reserved for VIP customers maybe. And lastly, the parking slot will be individual space within the parking lot where the cars are parked, like slot number 23 in lot A on the second floor. Great, so with that out, let's look at the structure of the database. Note, Supabase uses Postgres, so if you're not familiar with some of the data types used, I'll leave a link down below for further reading. Now that we have an idea of how our database should look like, let's finally create our tables on Supabase. There are two ways to create the tables on Supabase, either using the SQL editor or the table editor. With the SQL editor, you need to be familiar with the SQL language. For simplicity, you can use a table editor, which we will proceed with. In the case where you need to run any SQL query, SQL editor is where we go. Now let's start with a public schema and create our three tables. First, we'll have the profile table, so we'll proceed to click on create a new table and we'll give the name of our table as profile. The work of this table is to hold information about the logged in user or the user who is getting into the system. But please note, this tutorial focuses on the Supabase database feature only. Once we interact with the authentication feature, there will be advanced changes, but nothing to worry about for now. So we'll proceed to insert a description here. Then there's this part that enables row level security. We leave it as is. In the later lessons, we'll discuss what this is in detail. We'll also leave the real-time disabled. This is another important feature that is provided by Supabase. We'll discuss it in a later tutorial. Now we can define our columns. In a database, there are fundamental elements called keys. Keys are used to identify, link, and ensure the integrity of data within tables. We'll interact with two main keys. There is a primary key. The primary key is a unique identifier for each record in a database table or each row in a database table. Each table can have only one primary key column. Some of the characteristics are each value in the primary key column must be unique. Primary keys cannot contain null values and can be a single column or a combination of columns. Based on our database design, all our tables will have a primary key column. Then we'll have another key called a foreign key. A foreign key is a field in one table that uniquely identifies a row of another table or the same table. This can be one field or a collection of fields. The foreign key is defined in a child table but refers to the primary key or a unique key in a parent table. Some of the characteristics are it establishes and enforces a link between the data in two tables, and also ensures referential integrity by making sure that the foreign key value in the child table matches a primary key value in the parent table. We'll be defining a foreign key column for some of the tables, but not all. Back to our table. By default, when you create a new table, it comes with two columns. The first column is called the ID, which is set as the primary key. You can change the name of the column to your liking. The second column holds the timestamp of when the record was created. The column name is called created at. We'll retain these two columns. Then let's add other columns. We'll have a column named name. This will hold the name of the logged in user. It will hold a data type of text. Next, we're going to have a column called phone number, and this will hold the phone number of the logged in user. It will hold the data type varchar. Then we'll add another column called email address, and we'll give it the data type of varchar, which also represents the email address of the logged in user. Then we can proceed to click on save, and we're done creating our first table in our public schema. There we have it. Before we proceed to the next table, I just want to show you a step where if you need to edit the columns of a specific table, all you have to do is click on this these dots, and then you'll click on edit table. And then, for example, I have decided to make sure that the phone number is unique. I just come to the settings icon over here and set it as is unique. And then after doing that, make sure you click on save. So that's how you get to update your table within Supabase. So now that we have that, let's create another table. So to create a new table, we just come here and click on new table, and we'll proceed to create the vehicles table. The work of this table is to hold information about the vehicles registered in the system. So we'll retain everything all the way here, even the two columns, and then proceed to add our new columns. So we'll first have user ID. This will specify the owner of the specific vehicle. So we'll have the user ID, and then we'll give it a type of int8. Then at the bottom, there's a section where you get to create a relationship or foreign key relation. So all you have to do is, because we want to create a relationship between the vehicle table and the profile table. So we'll just come and click add foreign, and then we select a table to reference to. So we'll just click on profile because that's what we need. So in the vehicle table, we want to create a relationship between the user ID column and the ID column in the profile table. So simply that's what you do, and then you click on save. There are other settings that you can do, for example, delete cascade or update cascade. What that means is you can automatically set that whenever the child record is deleted, the parent record should also be deleted, or if whenever the child record is updated, the parent record is also updated. But we'll just leave it as is right now by setting no action, and click on save. The next column will be the car model, and we'll give it a data type of text. It defines the model of the user's car. Next, we'll have the car number of data type numeric. This you can change it according to how you set your car numbers wherever you are. But for this one, I'll just set it as numeric. Then lastly, we'll have the car color. I'm counter checking with the data schema, and then we'll just set it as text. Let's just make sure when we're adding all this, the user ID is not nullable, and also the car model is not nullable, does not return null. That's what it all means, even for this and for this. So we need values passed in. That's what it means. So let's proceed and click on save. So we have one relationship we've created between the profile table and the vehicle table. I forgot to create a description for this vehicle. So let me just add that. Click on save. Great. So now we have two tables. Since the remaining table in the public schema depends on another schema, another table. Let me show you. So the remaining table in our public schema is favorite, and it's dependent on a relationship with. We have a column called parking area ID, which creates it's a foreign key that creates a relationship between the favorite and the parking area. And for us to completely finish this table, we'll need that parking area. So the thing that I'm saying is that we can now proceed to switch our schema from public to parking and create our parking area. Then we'll go back to the public schema and define our favorite table. So now that we're in our parking schema, let's create a new table and call it parking area. We'll give it a description. So it holds a list of parking areas. I'll share a CSV file in the GitHub repository where you can actually upload some of the list of parking areas for your own testing. We'll leave the settings as they are, and it comes with the default columns. So now we can proceed to add new columns. So we'll add a new column called name, give it the data type of text. Then we'll just make sure that it's not nullable. We'll add a new column called parking fee and give it the type numeric. This refers to the fee or the cost of the parking in that specific parking area. Then we'll add another column called location text. Other than the name, you'd want to provide more information about where this parking is. So we'll give it the data type of text. Then before we proceed, let's have a quick look on PostgreSQL extensions. I felt like this specific table will be a nice table to talk about it. So extensions in PostgreSQL are packages that add functionality that isn't part of the Postgres core, what's already in the core. So extensions are whatever is not in the core, that is. Like maybe we have default data types that are usually in the core, but to access other types of data types, you need to add an extension to the Postgres core. So I'm going to use this parking area, just create a simple column. We don't need it based on our schema, we don't need a column. I'm just going to add it and then we're going to remove it just to showcase on how to add extensions to your table. So what I'm going to do is I'm just going to click on save on this specific table. Let's just click on save as is. So what I want to do is to allow us to create a column that will hold coordinates of a parking area. Okay, so coordinates is where you hold the latitude and the longitude. So to be able to store coordinates in our PostgreSQL database, we'll need a specific extension in Postgres, and there's one that's available that's called PostGIS. So to add an extension to your project, all we have to do in Supabase is we head over to our dashboard and go to database. Then we have a list of menus here. We head over to extensions. Then we search for the specific extension that we need. And in our case, we need the PostGIS. So just enter PostGIS and here we have it. And all you have to do is just enable it, as simple as that. Just confirming by saying enable extension. So it will enable the extension for us. So when we proceed to go back to our table editor, then we head over to the parking schema. Here's our parking area table. So we'll just click on edit table and let me show you how to create a column that holds the coordinates. So if we create add column, I'll come and give it the name like location point. And then if I want to set the correct data type that holds the coordinates, it's the correct data type that holds the coordinates in Postgres is called geography. And we can't access that data type without the extension that we have enabled. Now that we have enabled it, we should be able to see it. And here we have it. So we're going to just click on geography. And there we have it. And we're able to proceed to save our table. So that's how you use PostgreSQL extension. How to add extensions in the core is as simple as that. So now that we understand that, I'll just remove this column and we can proceed to create the rest of our columns. So now we'll add a column that will hold the rating and it will have the data type int2. Then we'll have another column called local description. This refers just to the description of the parking area. Description. Yep. And then we'll give it the data type of text. Where's text? Yeah. And then now let's have a look at arrays. You can also set your columns in arrays. So when working with arrays, it's very, very simple. Supabase made it very easy for us. All you have to do is set a column with a data type of text. So in our case, we have two columns that we'll need to set as arrays. We have location images that will hold the URLs, a list of image URLs showcasing the parking area. So we'll just give it the name location images, and then we'll just set it as text. And then we'll head over to our settings and just define it as an array. As simple as that. Now let's proceed to create another column called amenities and do the same thing. It will also hold a list of amenities in that specific parking area. So we'll click on text and define as array. And just simple as that, we are finished with designing our parking area. So we can just proceed and click on save. So back to our public schema. We can now finally design the remaining table, if you remember, called favorite. So let's just create a new table and give it the name favorite. And we'll give our description here. For a specific user areas, because one user may have multiple favorites. Great. So we'll leave the settings as they are, have our default columns, and now let's proceed to add our two columns. So if I go back to the schema, if you look at the favorites, all it has is the user ID and the parking area ID. And what's unique about these two, these are a collection of foreign keys, because this user ID creates a relationship between the favorite table and the profile table, and this parking area ID creates a relationship between the favorite table and the parking area table. So that we'll be able to do that quite fast. So we'll have the user ID, we'll give it int 8, and then we'll proceed to add another column. Let's just add both of them. Parking area ID, and give it let me just name it properly, and give it int 8. Then just proceed to down below and add our foreign key relations. So we're creating first a relation between referencing to the profile, and then we just want to connect the favorite user ID with the column ID in the profile table, and then we just click on save. We also want to create another relation reference to, we're going to reference to the, let me select the right schema, which is the parking schema. In the parking schema, we have the parking area table. So we're going to create a relationship between the parking area ID with the column in the parking area, which is the ID, which is a primary key, and then we click on save. So now we have our two relations here. Now we just click on save and we are done. Back to the parking schema. Now we are done with the public there. So let's create a new table called parking detail. This will contain information, parking information for a particular user. So we'll leave the settings as they are and proceed to add our new columns. So our new column will have parking date, and we'll give it the data type of date. Let's make sure it's not nullable. That's an important information from this table. Then we'll have the entry time. We'll set it with data type of time. Add another column and give it the name duration. This will be in hours. I will have defined it in the front end. So just give it int 2 and make sure it's not nullable. Then let's add another column for exit time and set it as time. Let's add another column for parking area ID. Int 8. This will allow us to create, this column will create a relationship between the parking detail and the parking area. So the beauty of having this relationship is that I don't need to have the whole information about the parking area that the user has booked. All I need is a parking area ID. And through this ID, I'll get the rest of the information about that parking area. So that's the role that foreign keys do. So that we're creating a relationship so that all I need to do is save the reference, which is the ID of the specific parking area. And then with that reference, I'll be able to head over to the parking area through querying, of course, and get more information about this parking area. Next, we have, what else do we have? Let's add the user ID, which will also allow us to create that relationship. We'll just have data type int8. So if we want to know which user has booked this, created this specific booking, we don't need to have all the information about the user here. We have a reference to the profile table. Great. So we'll create the relationships down below. Let's just make sure we have all our columns. So we have the parking area ID. We also need the vehicle ID. So int8, which will be a reference to the vehicle table. And then lastly, I think we'll have the parking slot. We'll add that later because we don't have the parking slot table yet. We'll add that later, which I think will be the next table. So let me just delete that. Just make sure that it's not nullable. Great. So now we can save this. Before we save, let's add the foreign key. So we have 3 specific columns that we need to create a relation with. So we'll start by, let's see, we'll start with the parking area. So all I need to do is specify the correct schema, which is parking. And then we select the parking area. So we'll pick the parking area ID column and create a relationship with the ID, the primary key of the parking area table. Click on save. Then let's add another one, which will be for the user ID, which is in the public schema, which is in the profile table. So we'll just create a relation between the user ID column and the primary key column of the profile table. Click on save. And lastly, we'll have the vehicle ID, which is in the public schema, and we'll just reference to the vehicle table and create a relationship between the vehicle ID column and the primary key column of the vehicle table. Click on save. So we have another one that we'll add over here, but let's first create its table. But that's all we need to do on the parking detail table. Let's click on save. Before we proceed to creating the next table, I just wanted to talk a little bit about managing enums. So Postgres also supports data type enum, which you'll have to create it on your own and define it as a custom data type. So let's say, for example, in our backpacking detail, if we wanted a column that holds status, for example, if the parking is ongoing, completed, or cancelled. So if I wanted to hold such a status, enum would be a perfect data type to have. Instead of having to define the text itself, like the actual text ongoing, completed, cancelled, I can have an enum variable that will hold them, and then all I have to do is just reference from the data type or the data type itself. Let me show you what I mean. So let's proceed to the SQL editor. I can just continue from here, or let me just create a new query. So let's say I want parking status, 3 parking statuses: ongoing, completed, and cancelled, but I want to set them as a num. So what I need to do is I need to create a custom data type myself. So I'll just use the create command and then define a type and give the name of my data type, my custom data type. And in our case, we can just define it as parking status and then define it of which as a num. That's how you do it. And then now you define all your variables. So we have ongoing, we have completed, and then we have cancelled. So those are the 3 statuses that we want to hold. Okay, so now we can run this code, this query, So it's successful. So we now have this type, custom data type in our premise. So what I want to do now is in the parking detail table that we have, I want to alter it a little bit and add a new column called status that will hold a data type of parking status. Now this is what we set as a data type because we have already created it. It should be accessible. So we'll just say alter table parking detail and add a column called status. We'll proceed to remove it, but this was just for us to understand how to manage enums. So we'll define it to the data type of parking status, what we've just created, and then set it as not null. So let's try and run this and see. So I'll click on run selected and it's successful. So I'll head over to my table editor, head over to my parking schema on my parking detail table. I should be able to see it, as you can see. So we have a column called status of data type parking status. So this is it's set as a category of other data types or custom data types that you've created for yourself. So when you click on this will hold the three statuses, and all you have to do is save based on either it's ongoing, completed, or cancelled. So you only use enums whenever you want to just set predefined constants within. So that means whatever you're going to save in that specific column is either or whatever that you have set as constants in this specific custom data type that we have created. So only this constants will be set. So if somebody decides to add another type of constant, for example, pending, from the front end, it should not be able to save because already it knows that this custom data type only holds three types of constants. I hope it makes sense. Next, let's create the parking slot table, which was what was pending in there. We needed a column that holds a relationship between parking slot. But before that, let's proceed to create the parking flow. Let's just create the parking flow first. So we'll create a new table, name it parking flow. This will just contain a list of names of parking floors. Simply as that. Then we retain the settings together with the two columns and just add one column called name of data type text, not nullable, and click on save. Done. Let's proceed to parking lot. So create a new table, call it parking lot, and we'll give it a description. So it will contain information about contain a list of parking lots for specific parking areas. Great. So we retain the settings as they are and then proceed to add a new column. So we'll have two columns. We'll have the parking area ID, which makes sense. And then we'll just set it as int 8 and set it as not nullable. Then we'll add another column for parking floor ID, int 8. And then let's create a relationship. So we want to create a relationship, two relations. So the parking area ID will create a relation between the parking lot table and the parking area table. And the parking floor ID will create a relation between the parking lot table with the parking floor table. So here's the kicker. So parking lot, we have a parking area. A parking area has multiple parking lots, and each parking lot has a number of parking floors. Okay. So that's the idea. So we need the parking area where this parking lot is. And then because you're going to have a list of parking lots, we'll need to be able to have a record of which parking floors that this parking lot has. We'll get to see it once we input. We have some data entry into the tables, and I'll be able to share the CSV file for you to just add it to for your test in this tutorial. So now let's create the relationships. So we'll reference to the parking area, which is in the parking schema. So we just need the parking area, and we want to create a relation between the parking area ID and the primary key of the parking area table. Click on save, and we'll add another one. The parking flow is also in the parking schema. So with reference to the parking flow, so we're just creating a relation between the parking flow ID and the primary key column of the parking flow table. click on save, and then we can proceed to click on save, and we'll be creating a new table called parking lot. So it failed to fetch. Let's see what the problem will be. Not sure what the problem is. Let me try and remove this too fast and click on save. We see there shouldn't be a problem. Something to do with the relation. So let me just try again. Edit the table and add. So we have in the parking schema, we have the parking area, and we're connecting the parking area ID with the ID of the primary key column of the parking area table. Let's save that and see. So that has gone through. Let's edit the table again and add the second relation, which is in the parking schema with reference to the parking floor. We need the parking floor ID and create a relation with the primary key column of the parking floor table. Click on save. Let's try and save that. Great. So I'm not sure what happened, but we just returned the relations and we are good to go. Now let's proceed to create the last table, I believe, because we have designed, I think, all of them. We're just remaining with the parking slot. And remember that the parking slot, we also need to create a relation with it and the relation between the parking detail table and the parking slot. So let's just create that table and finish up. So we'll have a table called parking slot, and this will contain a list of names of parking slots in a specific parking lot. Great. So we'll retain the settings and then we add a new column. So our first column will be name. So we may have, as I showed, we discussed an example when we were discussing on terminologies. A parking slot will be like G1, for example, that means ground floor number maybe 1. So it refers to the names themselves, G1 or A2, depending on what the names that the parking area is giving the specific slots. So we'll just set it as name and give it the type of text. And just make sure it's not nullable. Then we'll add another column called availability, and this will be of type bool. So is it available or not? That's all it means. And then just make sure it's not nullable. And lastly, we'll have the parking lot ID, which will be of type int. And this is the column that will create a relation between the parking slot table and the parking lot, because the parking slot is inside a parking lot. So we'll just set it as not nullable. And now that we have that, let's just create the relation right away. So we are in the parking schema, and we just specify reference to the parking lot. And we just need to create a relation between the parking lot ID with the primary key column of the parking lot table, and click on save, and then we proceed to click on save. And with that, we have created all our tables. So in the parking schema, we have 1, 2, 3, 4, 5. We have 5 tables, and in our public schema, we should have 3, 1, 2, 3, which seems to be the case here. So we have 1, 2, 3, 4, 5, 6, 7, 8. Great. So we have finished creating or designing our tables. Now let's proceed to the next step. So to do that, we head over to the SQL editor. That's where we'll get to set our index in our parking area. So I think I can proceed to, let me just create a new query. And all I need is the create command. And we're going to define the index and give it the name IDX parking name on. We specify the table, which is a parking area, and specify the column that we specifically want to set the index on, which is name. As simple as that. So let's execute or run this statement. So relation parking area does not exist. Okay, so let me see if I set the schema. Let's try. And there we have it. So we hadn't set the specific schema, so it was going to search the parking area in the default schema. So that's successful. So we'll just set an index on this specific column, and we'll get to explore more now when we head over to the app level and perform a search functionality or create a query that that executes a search functionality. In our project, we'll create a basic function that searches for parking areas that a specific user has marked as their favorite based on the search text. So we'll use this in a different search feature on the app where the user gets to view all his or her favorite parking areas. So it will look something like this. I'll proceed to create a new query and I'll just paste the database function here and then we'll go through it one by one. Great. So now in the first line of the statement, it creates a new function, or it replaces a function, replaces an existing one based on the same name. So this is the name of the function. Next, we are setting the input parameters, which are two. We have the user ID, which will represent the ID of the user of data type integer, and we have another one, search text, which will be used to represent the name or the filter, the name of the parking area that the user has set, and it will be of data type text. Our next line will be return set of parking area. What this means is that it specifies that the function should return a set of rows from the parking area table. That's what it means. Now let's proceed to the function body. To know if which part is the function body, it's enclosed in dollar quotes. So these are the dollar quotes. So all this is a function body. And then we have the begin command and the end command. This denotes the beginning and the end of the procedural code. Now inside it is what now we have is called the query logic. So the next statement that says return query, this command just returns the result of the query that will follow. And the query will be a select statement, which is this. So what we are doing, we are selecting all columns. This means all columns from the parking area table. PA is just an alias of the parking area, which we have set here. And then we'll proceed to perform an inner join between the parking area table, which is PA, and the favorite table, which we have given the alias of F. Okay, so the join condition is that the ID in the parking area, this one, this part, matches the parking area ID column in the favorite table. Then we proceed to create a where clause. So what our where clause will do, it filters the result to include only those parking areas that are favorites of the user specified by the user ID, which is one of our input parameters. And then we proceed to continue our clause, and we're also going to filter the result by checking if the name of the parking area that have been returned contains the search text that the user has passed, which is our input parameter. And the good thing is that the I-like command is case sensitive. So that's what this query does. So it's selecting all columns from the parking area, making sure that these specific parking areas are part of the favorites table, and then it should be for a specific user ID which has been passed as an input parameter and should contain a search text that has been passed by the user as an input parameter. Simply as that. And then the last part that we haven't talked about is this last line of the statement, which only specifies that it specifies that the function is written in procedural language for PostgreSQL. That's all. So now we can try and run this function. So I'll just come here and click on run. And we have a error that says parking area does not exist. This is because we are not specifying the schema. So let's proceed to do that. So our schema is parking. Let's try that again. Let me see. Oh, let's just try and specify the schema again. And if we try and run that, it's successful. So no rows returned. So our database function is a success. So we have a function called search favorite. Now, in the SQL editor, you can proceed to use this function. For example, you can create a new query and say something like select all from search. Let me proceed to copy this function name and just say from the function name, and then you specify your input parameters. So maybe you might have a user of ID maybe 1, and then we proceed to have a parking name or a search text like parking. So it's going to go and check on the parking area if there's a name that contains the text parking, and also using the user ID 1. Okay, we can't execute this right now because our tables are quite empty, as you can see. So another way to do, I think this is the best time to actually sort this out. So let me go back to the public schema. In our public schema, the favorite profile and vehicle will be generated. Data will be generated from the app level. But in our parking, there's data that we need to enter that will be used to interact in the app level. For example, parking area, parking floor, parking lot, and parking slot. Those are things that we can set the data inside the database. In a different scenario, we'll have maybe like an admin dashboard where data will be entered of all the parking areas, their floors, their lots, and their slots. So what I've done is that in the GitHub repository, the startup project branch, I have also added CSV files for parking area. So you'll have a parking area.csv. In the CSV folder, there's a parking floor.csv, parking lot.csv, and parking slot.csv. So let me show you how to import those CSV files so that you can have sample data that we can use to proceed to the next step. So what I'll do is in the parking area, all I have to do is click on insert, and then I'll say import data from CSV. Then I can just drag and I can just drop my files here. So I'll just go and look for my CSV file, which is here. And then what I want to import is the CSV file for parking area. So I just come and drag it there. Here's all the information. And then I just import the data. Let's see what could be the problem. Let me discard and do that again. Let's try that again. So I'll click on insert, import data from CSV, paste my CSV data income. A total of 5 rows will be added to the table. Here's a preview. What could be the problem? Location description is not present in your table. Location description. Okay, let me see. Wow. I must have written it in the wrong location. I wrote local description, location description. Click on save. Make sure the rating also is numeric data type. Now let's try again. Insert import data from CSV. Let me just drag, and now it's compatible. Now let's click on import data, and we have added 5 rows that consist of different parking areas. Now let's proceed to parking floor. I'll click on insert import data from CSV, head over to get my parking floor rows. Compatible, great, and click on import data. So it will have different types of floors that we can have: underground, basement. Then let's do the same for parking lot. Great, compatible, import data. And lastly, we have the parking slot. Compatible, import data. Great. So in our parking area, we have a list of parking areas. You can see there's some information here. And then we have parking floor, the different types of floors we can have. Then we have a parking lot. So it will be showing the specific parking area and the parking floors that it has. So if you look at this parking area ID, there's a parking area ID of ID 4. Let's check on it, which is Downtown Parking Plaza. It has, let's see, it has 2 floors. Okay, there's 1 floor of ID 3. Let's just check what that is, which is ground, and then 4, which is first floor. So it has a ground floor and a first floor. So that's how we're doing this. And then we have now, like for example, parking slot. Now the parking slot will hold a name. You can see the different types of names of slots that you can have, showing the availability in terms of true or false. And then we can have now the parking lot. So that parking lot, for example, parking lot ID 2, if we head over here and go to 2, we're referring to the Downtown Parking Plaza. It has Downtown Parking Plaza, the ground floor. Okay, so in this G1 represents Downtown Parking Plaza. That's the parking area name, ground floor, and that's what we're using. We're getting to know that information through the parking lot ID. And currently the availability is false, and the name of the slot is called G1. I hope that makes sense. So this is like sample data that we're going to interact with in our project. Great. So now we have a parking area, but we do not have in our profile, we don't have a user. Maybe if we try and add 1 user just to be able to check if our data function is working. But now we'll need to also add data in our favorite. And I don't want these tables to be inserted dummy data. We'll be able to enter data from the app level. So what we're going to do is Let me see. We're going to test this function. It's in our SQL editor. We'll proceed to test this function when we reach at this point where we already have at least a user and we have some favorites. That will help us because already in our parking areas we have some parking areas to play around with. So instead of just adding dummy data here, I really want it to be actual data from the application level. So we'll come back to test on this by just running this command, and then we'll get to see our result here. And in the app level, we will call this specific Postgres function as a remote procedure call. We'll get to see that step by step. So I will leave a link in the description if you do not have any idea on what remote procedure calls are. I'll leave the link down in the description. In simple terms, role level security allows us to control access to rows within a table based on specific conditions. It is particularly useful when different users, or we may call them roles, should have access to different subsets of the data in the same table. So what it does, it helps us enforce that data privacy and security policy by restricting access to specific rows based on a user's role. Okay, let's use an analogy to make it to explain it much simpler. So imagine a library with a large collection of books. The library has several sections such as children's books, adult books, and restricted books. Different visitors to the library have different permissions. So children can only access the children's section, adults can access both children's and adult sections, but only librarians can access the restricted section. So what role level security in a database, what it does or works simply by allowing you to define rules that determine which rows, in our analogy that's books, a user, in our analogy means visitor, can see or modify based on the role that they have. Okay, so how does role level security work? It involves two main concepts, policies and rules. So role level security uses security policies to define the rules for accessing the rows. Policies are where we are going to define the rules, or as we may call them, conditions. These policies detect which roles can be accessed by specific roles, which is our second concept. Access is often based on the user roles that have been set. So Supabase already have predefined roles that are already there that we'll get to see. And based on these roles, they have different meanings. There are roles that are authenticated, and there are roles that are not authenticated. There are roles that you can access without even a user account. So we'll get to see that. So those are the two main concepts. So despite however much explaining it in simple terms makes sense, most of the hard work comes when creating the policies, because whatever condition that you set in the policy will actually determine whether your table is, or whatever you have done is working as it should. So mostly the work is in creating the policies. Once you have the roles, you define the roles when creating the policies, and inside the condition you specify who do you want to actually see specific information. If, for example, I want to see my user profile, in the policy I need to specify only I should be able to see my own profile, right? So those are some of the things that are involved when creating policies. Those are some of the conditions that you put in. So just a brief on what are the advantages of role level security. Already, because it has the word security, of course it means it's important, but what makes it so unique? It provides precise control over data access down to the individual row. As I had said, when creating a policy, for example, for a user profile, you can create a condition to a point where you say a user can only see the row that has information of themselves, only their information, and you can't see the user profile or user information of other users. That's how down to the individual row you can go. Next, it also ensures that users can only access data they are permitted to see, which enhances data privacy and security. That's obvious. And lastly is that security policies are defined and managed centrally in the database. That means we're not going to create these policies in our application logic, okay? This is done all in the database, which reduces that need of complex application logic outside, externally, okay? So now let's proceed to create or to implement role level security for our project. There are 3 steps involved in implementing row level security. So first is enabling the row level security, and it's a feature that restricts, as I said, restricts access to specific rows in a table based on conditions you define. So when RLS or row level security is enabled on a table, PostgreSQL checks policies associated with that table for each SQL operation, which is select, insert, update, and delete, and determines whether the operation is allowed on a per row basis. So in terms of that step, enabling RLS, Supabase has done it for us, or we already left it as it was. If you remember, when we were creating each table, we left the enable RLS as active, as enabled, so we did not disable any of them. So we're kind of ticking off the first step automatically. Now, the second step is creating security policies. So in PostgreSQL, as I said again, a policy is just those set of rows that now you define to control access to now the rows within a specific table. Okay, so a policy defines the conditions, and you can create different operations for different operations like select, insert, update, delete. You may decide for select, this is the specific condition that you want to be executed in terms of in the policy. So for select policy, you're just controlling which rows can be selected. And then for insert policy, you're controlling which rows can be inserted, update policy, which rows can be updated, and delete policy, which rows can be deleted. And we'll get to see that. So for example, a simple syntax of how a policy would look like, maybe a create policy command. So how a policy would look like when you are creating a policy. So you'll need the create policy command, and then that specifies the condition under which the access is permitted. So you'll need to specify a policy name and then specify which table you want to create the policy for. And then we'll have the operation. The operation, as I said, is either the select, insert, update, or delete. And then lastly is where now you define the condition, and this condition to either return a true or a false. So it's a Boolean expression, and it defines whether the policy allows the operation on a row. But not to worry so much, because Supabase auto-generates some of this part of the policy based on what we select, and you can edit the condition accordingly. So policies are automatically applied once created, so you don't need to execute anything else. Once you save the policy on a specific table, it's automatically applied. So in this tutorial, we'll define our conditions as simply true. We'll just enter the condition, the text true, because we're coming in as unknown users, and we'll get to talk about that in a few. So the third step is adding a role. So PostgreSQL uses roles to manage access permissions. We mentioned that, and Supabase maps every request to one of the many roles that it has, but mainly we have two. The unknown, which is an unauthenticated request where the user is not logged in. So an unknown role does not have a user account but has public access to the database using an unknown API key, and that's how that's the role we're going to use when interacting with Supabase database from our app level. Will be unknown users. Then there's the authenticated role, which is an authenticated request where the user is logged in. When we come to the next tutorial about Supabase auth, that's where we now implement authentication. That's when now we'll switch from an unknown user to an authenticated user. So in this tutorial, we're not managing authentication yet, so we will execute our request as unknown users and advance as we go. Great. Let's perform these steps on our tables. So the first step is enabling our row level security, which we already did. We made sure that every table that we created, both in the public and the packet packing schema, the RLS is enabled. So step 1 is out of the way. So the next step is step 2, and they'll go hand in hand with step 3. So we'll proceed to, we can start focusing on the public schema first, and I'll start with the profile. So what is involved in step 2 and 3 is creating policies and also like setting the roles, and we do this in one place at the same time. So to create a policy, we'll head over to view policies. So we're working on the profiles table first. You just walk with me every step and I'll explain in detail in everything that I do. So we'll click on view policies. So currently we do not have any policies. We have row level security enabled, but we do not have any policies set. So what we'll do, remember we said we have 4 operations or 4 types of policies that we can create: select, update, insert, and delete. So for the profile table, the operations that we'll need, it will be select, where we'll need to read an information about a specific user. So we'll create a select policy. We'll also need an insert in the point of where we are signing up, and we want to add the record or the information of the user who has signed up into the profiles table. So we'll need an insert policy, and we'll need an update a policy where we'll have some information. If we head over to the table editor and just proceed to the edit table, there's a point where we'll need to add the phone number, and it's not straight from the sign up. So this is a situation where we'll be updating an existing record already, so we'll need an update policy. So let's go back to view policies and start creating. So we'll create click on create policy, and then we'll come here and do let's create first a select policy, and then we can specify which type of user. We are unknown users, so I'll just select that. So as I said, Supabase already auto generates for you some part of the policy, um, the policy that you're supposed to create. So already it's creating a policy called we can give it a description here. So let me just use an example, like let's see, let me just select this. I just need the examples of descriptions that they have. So I'll just click on select, and I need to set the role as unknown users, and then I'll just update the description or the policy name, enable read access for unknown users, and then it's going to be implemented in the profile table, and it has specified, let's specify the role. I seem not to have done that. It specifies the role to an unknown user using, so here is where you set the condition. But I mentioned previously that in the policies that we're going to create, since we are working as unknown users, I'll just set the condition as true. There is no complex condition that I'll set here. I'll just set the Boolean expression to return as true. So I rate it as is. As long as it's an unknown user, we'll just let it go through for now for this specific tutorial where we're talking about Supabase database. But when we get to Supabase auth, we'll need to like validate a few things here. And if it comes out true, that's when the user will be able to, for example, do a select statement. If it comes out false, they cannot select. So that's our first policy. I hope it makes sense. So we have the policy name, we have the table that we are setting this for. We have made it to be permissive. We have defined our policy command or operation as select. We have defined our role. So those are step 1, step 2, and step 3, and we created our policy over here and set the condition as true. So let's save policy. Great. I've said another operation that we'll need will be the insert in the point of sign up. So we'll just do the same thing here. I'm just picking some of the templates that they already have, then I change it to my liking. So I'm just going to say enable insert for unknown. So I'll remove authenticated and just specify as unknown. Let me just remove authenticated, and then I just come in and describe the policy name properly. So unknown users, sorry, I need to set it over here, unknown users. And then we have our table on clause, and then the operation that we're setting is an insert to an unknown role, and we have set the condition as true. So we can click save on that. Then lastly, we'll have the update in the situation where the user needs to update existing information. We'll have that in the app level. So we'll just create update. We're just using existing template, enable update for users. So I'll just specify unknown based on user ID, or just say enable update for unknown users. Just make it simple, and then we'll come here, and as you can see, for this specific template, it has a condition set. For us, we're not basing it on email where we need to do some create a Boolean expression. So all I'll just do is come here and just delete all this. But this is an example of what happens in the what you're supposed to insert in terms of the condition. There are a few things you need to set in. So I'll just delete this. Let me just choose, I've just taken a different template. Then I'll just remove all this, set to true, go back to setting the name that we had, which is enable update for unknown users, update profile, and then we specify here unknown. So we're creating a policy, an update policy for an unknown role, and we're setting it as true. Simply as that. This is the bare minimum of creating a policy. So now we have set policies for our profile table. The reason why we are doing this again is that in case, for example, if we finished up with setting up on Supabase and headed off to start integrating or interacting with Supabase from Flutter, if we tried to connect with or communicate with the database, mainly the profile table in this case, we will not be able to get the information that we need because we don't have any policies. We enable the row level security, but we do not have any policies. So it's set, so we'll get an error. There's a specific error code that we get. I'll get to show you that. So we need to do this to all of them. The fact that we have enabled RLS, which is a good thing. Next, we're going to have vehicle. click on view policies and we start creating. So for the vehicle table, we'll need two operations where we'll get to select information about a vehicle, and we'll also get to insert a vehicle record. So we'll just proceed to create policy and do a select, and then just say enable access for unknown users, and then select, specify the unknown role. So that, and then we make sure the condition is true, and then we just save policy, done. Create another policy now for insert. We'll just enable insert for unknown users only on the vehicle table. Insert, specify as unknown, the unknown role, and then we just confirm our policy is okay, set to true, save, and we're done. Now let's proceed to the next table, which will be favorite. So let's create, for favorite, we'll need an insert, obviously, because if the user saves a specific parking area as a favorite, we'll need to insert it in the favorites table. Then we'll need also the option to select, where we get a list of favorites for a specific user. So we'll need a select policy. We'll also need an update policy, where we'll need to update specific information. In this case, if the user has unset it as not favorite, or we can also create a delete policy instead, where we can allow the user to delete the parking area as no longer a favorite. So let's just create the four operations. We see whether we'll need the update, but we'll definitely need the delete policy. So we'll just start with select for unknown users. I'll move fast. Public select, and then I'll just proceed to select an unknown role, and then make sure it's true. So we have our select ready. Then we create a policy for insert, unknown users only, and then we just proceed to specify our role, which is an unknown, set to true, correct. Then we can proceed to update. Let me just pick a simple template there and just say enable update for unknown users, and then we'll just make sure that it's for the unknown role only, and then we'll just remove all this, the condition, and just set it straight to true and save this. And lastly, we'll have the delete, which will be enable delete for unknown users, and then we'll just specify our role and just set this straight to true. When we get to interact with Supabase auth, you see these are examples of conditions that we'll need, or Boolean expressions that we'll define. Okay, so that is true. So we click on save. So we have our four policies. Great. Now I think we are done with the public schema, so we can proceed to the parking schema. For the parking schema, we can start with the parking area. Great. So for the parking area, the only thing we need to do is just select or get the list of rows from the parking area table. We're not going to manipulate that table. We are taking it as an assumption where we have an admin portal where parking areas are being inserted and validated. So what we're doing from the app level, we need to just read that information. We're not supposed to manipulate it. So it will just be a select policy. So I'll just click on select, enable for unknown users, pick the unknown role and set it as true, save policy. Great. Now the next table will be parking detail. View policies. So for the parking detail, whenever a user decides to select a specific parking area and books it, that's insertion. So it will need an insert policy. And also we have a tab in the app where we'll need to view all those bookings the users has made, so that we'll also need a select policy. So those are two policies that we need. So we'll just click proceed to create policy. We do a select and specify here for unknown users, and then we select our role and make sure it's true, save. Then we'll also need an insert policy. We just click on one of the templates and change it. We don't need the authenticated for now. We need an unknown role and make sure it's true, and click on save policy. So we're done with that. So our next table will be back to the parking schema, will be the parking flow. For the parking flow, all we need is just to get records from that parking flow. Almost it's the same concept as the parking area. Actually, all the four tables that we imported data from an CSV file, we just need to read records from those tables. We don't need to manipulate them. So no, wait, there's one of the tables I will need to manipulate in terms of availability. Sorry about that. But most of them, the other three, it's mainly the select, where we just need to read the records and display them on the Flutter application. So just do a select, create a select policy for unknown users, and we just define our unknown role, and then we have our policy here. We have the correct role set, and we set the condition as true, and we are done. Back to our schema. We have parking lot, view policies. We'll also need a select policy alone, as I mentioned, for unknown users, unknown role, set to true, click on save. And the next table will be back to our schema. The next table will be parking slot. So for a parking slot, as I mentioned, we need the select policy like the other three, but we'll also need an update policy, because it's a place where the user, when the moment they book a specific slot, since it was available, once it's booked, it ends up being no longer being available. So the availability will be false. So we need to update that. So we'll need an update policy. So let's just first create a select for unknown. Unknown. And then we make sure the condition is true. And then now let's do the update. Create policy for update. For unknown. I just remove this whole Boolean expression and just set it to true and click on save. And there we have it. If I go back to the parking schema, we are actually done. Awesome.